Hi everybody, good morning. This is a nice cool forensic room was out yesterday. File curving, learn about forensic technique known as file curving. So it's a bit different. This one is not like we use deleted file and things like that. So basically it's good to uh, yeah, it's good because especially for the offset and partition, something like that. It's good to these couple of rooms in same concept, because this is a new series of TryHackMe. I think for forensic they doing it for hard drives. It was Windows, Linux, like file system, FAT32, NTFS and EXT. So the introduction, of course, is about file curving, is about technique to digital forensic, bridging the gap between low-level storage analysis and recovery of a critical evidence. They talk about an NTFS, FAT32X4 Linux, fail to provide precise metadata. This is basically when a hard drive is corrupt or formatted or something, and there's two ways you can do it manually, which should be time consuming, and there is also you can use tools. The tools we'll check them now later on, especially now in this one, Kelvin tools. Uh, and then it tell you non-guided challenge in number 6. So this is walkthrough, but number 6 you do it for yourself. And then there's like a type of scenario that there is a mid-sized tech company data sync TryHackMe solution sorry, has been acquired by a large conglomerate, Integritech Inc. The accusation is to merge technology and operation data. During the transition, Integritech suspect that the R&D department at DataSync may have mishandled proprietary information during the acquisition. Key areas of concern include we have 3.1 critical file that appear to have been intentionally deleted, so know how to recover this deleted file. Hidden data and suspected to be embedded or concealed in a company storage drive, and the use of unconventional storage practice to obscure proprietary information. So now we're playing the role of an investigator, and let's see. Now, what's happening? No answer, so it should. What happened with your TryHackMe? I start the machine here, so uh, TryHackMe sometimes you like to play games with us. Oh no, done basic file curving here, but because here very distinguished difference. This is a not free room, so I'm zooming in text and someone can read. So recovering data from storage media is critical. One of the most effective techniques for doing is file curving, which allow forensic experts to extract file basics solely on their content, bypassing traditional file system metadata. Before we dive, so basically here not the usual one, it's easy like use it's like already there's no corruption in the data, there's no variety, just use certain software and recover the whole thing. Now here's a small introduction. As I said, there's other rooms of TryHackMe that go deeper on this. You can go deeper in these rooms. So this one is just a reminder about this. So we talk about Windows FAT32, the NFTs Windows, and how master for the MFT attribute and data run for the MFT, and then the system file special file prefix with a dollar sign. And remember, this is a room we did. I think the before the last one. No, the last one. The MFT, the data, and dollar $J and all of that. For the Linux is not too complex. The new one is ext4. Linux use inode structure and block inode. This room I think it's more Windows oriented. Then we have file and header, because now this is very important to answer the question later on. So for each file they have the what they call it magic bytes. So we have the start, how they start. This is how they start for each different files, and that's how they end. So we can find the start and end of the file when we do it in hex editor. Of course we have this one, we needed this one to give us the whole list of files, so we can easy to look for them. We'll get it later. Then we have the metadata is the data that provide information about other data in the contents of the file. Metadata describe attributes such as creation date, modification, especially Linux. Then they have embedded data, extended data, and external data. So the person who have, if you have TryHackMe subscription, you can read on detail on this. File carving is the process of extracting file from raw data without relying on file system metadata. Basically, you're going blind inside the hard drive. So application of file recovery, deleted file. One file deleted, the file system may remove reference of them. That's why you don't count too much in metadata. It's extracting data from corrupted drive. So this is very important. And then recover hidden and temporary file used for in investigation when data has been deliberately concealed or altered. Now, the process of file carving is scanning for signature. That's why we said especially this. For example, you say, okay, I don't know what's inside the file, but let's assume they're looking for images. Let me look for PNG. Let me search for this in hex for this. If there is this, it means it's JPEG. If there is this, it means there's an image. And then if I find this and then I search for the end, and then we have the whole hex, just copy it. Data recovery vs file curving. Data recovery relies on file system metadata. Uses information like that to extract and file and all of that effective when metadata is intact. Employs standard recovery software. For file curving, bypass file system metadata. Effective when metadata is missing. Tools. Yeah, specific tools. We'll see them now. Limitation, of course, data recovery for the corruption or something, fragmentation doesn't really work well. For rule of overcome metadata loss and fragment file. Now there is the quick question. Now he said, what is the file signature of JPEG? JPEG is, they already gave that here, so we can just use that one. Then the next one is what file signature is it on the file Windows shortcut. The shortcut is LNK, so you can see it's LNK. So if I come here and just Control F, LNK, so we have Windows shell link shortcut. Is there anything else? That's the only LNK. So we can just copy C. Should be this one for the LNK. Now the tools. Of course, now the tools in the no. Let me come back to this machine. In our machine, they give us this. This is just shortcut. This is the hex they're using in this machine. We're using this hex editor. If you do the other room, this is usually it's different the one we used before, but it's still working. Binwalk is well known. Scalpel. In this room we'll use this. We use the hex. We use the foremost. We are not using these ones. If you look for them, this one photo rec, and then we have this is foremost. By default is in Kali. Scalpel, it's very old. Binwalk, yeah, it's well known Linux system. This one, it's the hex. So what's going on here? Let's zoom it there. This is the hex. Usually if you got used to hex, let's open one so we can the challenges in the room is in the desktop Carving challenge. The first one is this USB one. Let's let for not freezing. So basically this is the tools we talk. Now we better way to understand them is practice. Okay, manual. The first one we do in manual curving. The scenario is we see that the acquisition of the sync TryHackMe has resulted in many suspicious activities among disgruntled and recently terminated employees, such as wiping USB drive that were. That's why we're opening now the USB one. Is it opening? What's wrong with you? In their possession. As a forensic analyst, your work is to recover the files information hidden within USB image. Of course, if you follow the room that MBR, this is an MBR room. This is the MBR room. So Here it would show you about especially the first part of the MBR, so you know when it's not corrupted. In our case is corrupted. This is the first region of the MBR. So um, as I said, for now, for example, now you can say if you go back to not this MBR, if we go for example the table that we had before, now you can say, okay, how come let me search for example if there is an image, so I can just go there. Let me take spaces out, so I can just say, okay, I can do file, and you can just click here, find. Let's find it's next to you in this one. So it's hex, so you can paste. Why suddenly you don't paste anymore? What's going on? Sometimes it works, sometimes he want you to type. Okay, FD 8 FFE 0. So if I search there, if there is a JPEG image, for sake of argument, he said doesn't work. Let's now look, no, not next. The Now look for PNG file. No, it doesn't show. I know it doesn't go. It's not pasting for me. Sometimes this it was working and then it stopped working. Okay, let's copy it from here. I don't want to type. So if it's a PNG file, if you look in the hex, you should find something like that. Don't tell me I need to type this now. So if I search, let's see, if I come here, you can see it's written PNG. So at it start 89 at offset 001 06 905. The offset, you can see it in the line there. So we know there is an image. Now the question is, let's say if you follow this story here, now if I follow the manual curving, so we have that, uh, this is the range, and then they show you how to do it. Let's understand it here. So basically we know the offset. Is there text file I can write here? Just open a file and let me open something, so we can so we can put our finding here, so we can know. Just that vim finding.txt. So I know there is we got there is a PNG image, uh, start offset. The offset is 0001069.056. The offset is the line. You can see it starting there, and if you just put your cursor here, it shows you in the bottom. If you follow, let me put this one up. No, I don't want it zoom. Yeah, it's fine. You can zoom. You see in the bottom left corner of my screen, you can see when I'm moving the mouse, there is a word called offset. I don't know how to make this bigger. Let me zoom the text for a moment. Let me find it again so everybody can see. You see, this is the offset. The line is start 001, but you can see it in the bottom. Look for the bottom, and when I put my mouse, just put the mouse in the front, it will you the offset in the bottom left corner. Offset. I don't know how to zoom this part. It's too smudging each other. I'm not sure why you're not showing it. Let's see if you can do a view something. Offset coding, show value coding. it's better if you have it show here. It's not there in the bottom. I don't see any case. So we know where it starts. So we got an image that's called PNG file, and we have started this position. The next one, we need to know where it ends. We know how it ends because if we come here, the PNG start this and it end in this. So we can just copy that. That's the footer, the end. So if I go there and I put these numbers, let me put them. So the end, we have the signature and this. So then this is the when you have a PN. What's going on? When you have a PNG, that's how it should end. And if you find this, you know the file where the file end. So basically now, if I search for this, if I go now find, and this time I'm looking for this now, the end of the PNG now, and then we have the end of the file. You see now the end of the PNG where it ends. You can see here, and that's how the PNG image end. So we have it here. Just give me a second. Close the window. It's a bit sun is cooling my eyes now. Sorry, 1 second. Okay, I close the window, the curtain. So you can see now this is the end of the file. So we know the 49454E is the end of the file. So we know the end. So now we need to get the offset. How to know the offset? It's different way you can do it. You just can put your mouse here. You can see this next to 49. If I put the mouse 49 in the bottom, if you look here in the bottom, it's written offset. In the bottom, I can see end offset. You can see in the bottom it says 00152646 because it's here. If I want now to look to it in different way, because you just put your mouse, where is it? I'm confused now. Where is that 49 45? I can't see. Yeah, the 4945. You put the mouse there, in the bottom left corner it's written offset 00152646. Now if you don't know how to, or you can do it this. You can see this line. Let me push this so you can see it in the screen. Oops. Or what you do, you can see here this 49 line. You can see this row. Remember, this is a 16 block. 1, 2, 3, 4, and then 4, 4, 16. Then you have this line. You can see this block there. The blocks start with 0, 0, 1, 5, 2. This line 5, 2, 6, 4, 1, 6, 6, 4, 1, 6. So you can see that. And now the 49 is where it's a block. Remember, we count from 0. 0 byte to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's a 10th byte. So you can plus 10. This is hex. Because a small value, you can just guess. This will equal this. So it's not, if you count hex, basically 10 and 26. If you don't trust your math, you can just go online and do hex calculator. So is that just that 10 bytes and calculate, and you get 26. Let's confirm. It's 2217. No, we are wrong. What this calculator is calculating wrong? Well, No, in base 10, no, this, no, the, in base, no, this is decimal. When you, hex equal hex, it's 152, 152, and then 6426, 6426, that's the offset. So we have the offset and we have the start of it. So we have the start. So it's two ways. Just put your mouse there next to the 49 and look in the bottom here, bottom left in the hex editor. It shows you the offset. So straightforward. Um, and then yeah, this is basically the answer for the first question. If I do this is the offset for the footer, that what TryHackMe call it foot. It took me time to figure out this yesterday. It was busy late at night. So if we go now, there's a question. He said, what is the ending offset address of the PNG file challenge 1? The hint they updated yesterday said search for this, what we did, and click on the first byte, and this value include the beginning of 0. I don't know why they said including the beginning of 0, but I'm not sure the 0 should be there, and that's the offset. So the offset, I'm not sure why TryHackMe refer about the beginning of 0. Uh, because you can just click there and see the offset next to you in the screen in the bottom. It's written there 00. You can see on my mouse here and at the bottom left. Or you do the normal math. You have the line here is 0015 and 49 is 10, the 10th byte. Remember, you start from 0 and just do the hex 10 byte to that. Now we go to offset. If we go to offset now, straightforward, we can go with continue the challenge. So now one way for them to do that challenge is using this the Linux command dd. Did we jump in a step here? We are not. We're doing this. Oh no, there's another thing. He said Windows select range. N- uh, we can keep the hex. We should go. No, we need to go to decimal. I know TryHackMe sometimes it confuse me. This is hex value, so we know the start is from there. From there, let's see. Maybe it work for us. And then the end is this one. So if I do that, let's see if a selection work. Why my selection? What exactly did it select? Offset. Yeah, it's in a hex value. This selection things doesn't work for me. It's selecting. Let me go back to selection. Decimal. Why go to decimal? The first step is then with the header and footer offset. No, let's see. The value will allow us to select a range that cover all this data. Copy, it's a new file. The PNG, no, that PNG. This is the header for the PNG. This is no, we got 00, the offset, oh, the offset is 056, the same as we got us. So this one. And then we for the header. And what's this 00156 433? What that 433 got to TryHackMe from? Huh? Where you got this value from? This is the end of this. Let me go back to this. Sometimes this one confuse me. This is the end of oh, the was the value 6433. You know what that 6433 he got it from? 6433. It's not the offset I'm looking for. 19 double 2. This is double 3, the offset. The end of oh, this is the end. 00156 152 0015264 double 3, which is what TryHackMe is putting here. This is when you put your mouse on the last one for the end of the footer. Remember us, this one is the beginning, the beginning of the footer. It start with this offset, but the end of it is this one. So you put your mouse in the 50 and 82, it show you 001526433 in the bottom left. So I get the argument of 2643 significant bench must be stored here. Um, so 001699056, where they got that number again from? I'm getting now confused. So we know this is the end 9056. See, go with decimal straight, but I don't know why this number, because this is strange. In this image, it put the end offset at 044. I don't know why 044. And you go to straight to 149, which is out of range. 149. Not sure 149. Where is it? Because it's not there. All of them are not 149. I don't know why. So if I go to all offset in 82, but I don't think we need to go to decimal. I'm getting confused now. So if I start like in the image here, the 1069056, the start, let me do something quickly, guys. We know the start of a PNG is there, so if I do there, convert to decimal, decimal is 6819. So basically, so it's not this one. So why that's what I don't get, because I'm not going to decimal here. I'm in a hex offset, and the hex offset. So we know it start at offset 0056, because if I search find no, the offset is decimal. Oh, that's why it doesn't find it. It's not. I'm getting confused now. The end, we can go straight to the 82. I don't think we need to go straight, but let's play with that. 0015 2643 1526433. If I select, oh, now it's selected correctly as a decimal. I always get confused with the offsets. The offsets and decimal, it's a decimal, that's why you get confused with the math here. That 10, because it's 10 block bytes, so you just put 26, if I'm not mistaken, this part. Sorry guys, I'm getting confused now. So now we have the whole file, but how do you copy now? Save as values 8950. How many of them? copy to clipboard. Really, let's see if it does work. Yesterday didn't work for me, so I'm not. No, it froze. Let's go back here. And they said you can copy to file. Uh, let's see if it did copy it. Let's see. Let's see. Vim image dot png. It did copy it. Not bad, but it too much. But it's in hex. Let me make zoom. Is there export file to just export the file? Copy as. View in plain text. Let's see view in plain text. It do nothing. He said alternative. He said the value will allow us to select the range and convert this data, copy it to a new file, and save it with the right PNG extension. Verify in. Yeah, this things is not fancy. It doesn't save to view in a plain text. Doesn't control copy. You have the option to select, but it's not like copy straight to file, and then now we crash in the computer. It's still pasty. I think we did something wrong. I'm not sure if it's real, this what we're doing. I don't know why this TryHackMe. I think it's not the same room. It's doing another hard. In any case, let's wait for it. I don't know if it does work or not. The next one we're doing is the. Let me mute this. The next one using this Linux one. Let's copy this and then we apply that side. The Linux command for this is this one. So let's remove this. The cont home. You call it. Let's say TryHackMe image. Why the HD didn't work? BS1. The start, our start will be not from this point. The start, which should be where we got the start of the offset, is this one. And then we have, what is that calculator again? This is the footer. The end of the offset is this one. So we need to do this. Just put that there. Minus. Where is this is the start, so you can copy that. And then we have the difference. So it means start from the point where the things start, the image, the PNG start, and use all these bytes. So if things go well, we can get. Can't I? Oh, I need to go to desktop. Challenge. And then let's open that. Now, if the image work well, where is that? Let's look at it. Just open. Let's see if we have it. Desktop. Challenge. This is the image. Remember, we call it TryHackMe image. So this is the image that we got. It's a PNG. If we click here, detail, location. So now it looks fine, not an image like that. But now if I go to EXIF tool, what we called it? We called it TryHackMe image. Now we get the hidden files. We're supposed to get flag here. Oh, that's copyright TryHackMe or rate reserved, and then we got the flag here. So we got the first thing. So the text was hidden inside the image, this one. So we got the answer for second question because we got the flag for the image. Let's go back to our experiment. It's still pasting. I think we did something wrong. The computer might crash. I don't know how the hell to edit. Copy as. Even if select, I don't know how to. The only thing is copy, paste, copy as values. Uh, Even TryHackMe didn't follow the option. It just said you can copy. First step is to and then subscribe offset value. Okay, we did this, so we have that, and we did exif tool, and we got the flag. Let's continue for now, and then a recovering file from Slack space. Now. The file in the Slack space is of a former RD employee workstation storage using now using Binwalk. We can examine the file structure of the challenge Slack space. Now Slack space refers to the unused storage space within the cluster that remain after the file written data, which may still contain residual data from previously stored files. This means that, unlike in our previous scenario where the curving focus on seeking deleted or lost files by identifying their header and reconstructing data manually or with tools, here we start target residual data left. Now we're using Binwalk for challenge number 2. This one is still copying for whatever reason. Just let him. As long as it doesn't crash our computer, we're still fine. So Binwalk, if we Binwalk, we can just throw that in challenge 2 and let him think. For not wasting time, we can extract data in Binwalk 2. We can just do that, so we can don't wait. We can run again Binwalk with extract. No, Binwalk usually do -e challenge 2 to extract data, and let him extract. Here you can see start looking for, you find something mpeg, if you know, is mean it is audio or video or something, because you can see the structure here. So we can further understand the file signature by looking at them. Oh, let's go to the hex editor. So let's stop this one. This is the USB one. Close it. Close the USB one. The file. Let's open the Slack one. Let's not crash it. Let it do that, because if this one still. How big this image we got? It's still extra. Let's do some experiment. Maybe we just did something wrong here. Is there hex command line here? Hex edit. TryHackMe. Let's see. Oh, that's our image. We start with 8950. Same as we got. How to go to the bottom? I don't know. Just Control X and finish. So we have the image. This is our image, but I'm trying to. Why are there too many of them here? Any case, maybe there's an option. I don't know. So this one is still opening. Let's open computer. Maybe it's freezing. Now the idea, of course, here they tell us we can further understand the file signature by looking at them in our hex. Open the disk image and go to the offset 26. This is 26 wherever, because we notice there is a stream here, and this is hex value. So if you copy that hex and go to decimal. So if I go hex there and convert to decimal, you can see this value 594. So don't get confused when you tell you go to the offset 94 and you look here and you don't see it, or you don't because this is the offset for this hex. It's here already. Oh, I'm sorry guys, I'm confused. You can see it in decimal here. So we just need to go to this offset. Let's copy this offset. Oh, it open. Let's copy this. Let's see if it does work. Offset is file edit. Go to offset. Let's see if no, we go into decimal. See if I go there. Oh, now it work. Where is it? Why it came here? 47. 47 is the offset. Sometimes it confuse me, this left colon. Yeah, this is the 47. And then here, TryHackMe explanation, they said a little bit, I'm not clear on it. What we find is we are directed to the byte 47, which was indicated in the documentation as a representative of the transport stream data. However, this byte is in the middle of other data, which means we can find a very beginning of the data stream and define what file type this data represent. As the data is fragmented, that's our problem here. It will be time consuming to scroll through it all. Searching for common file signature byte is easy until we find any significant. So doing the manual way is complex and things. That's why we use in Binwalk. We can extract directly the files. Let's see if our Binwalk finished doing the job. So the first we can see the offset, we talk about it, is there. So we notes in this did we call, it's not finished yet. I think he got that. Let's see if he got it yet or it's still working, because no, it's still working. Let's continue in the room before. How is our friend there? It's still copy and pasting. Maybe just cancel it. I don't know if it will work. Or maybe I'm getting the wrong data. Now, challenge of manual file curving. Manual file curving is a connection, is cornerstone skill. Manually, of course, take time and things. Look at fragment, reconstruct file, address missing D. Manually is when really software can't work at all. Time intensive data, high data volume, complex. Let me make sure before we jump. Is the time still? I still have time. And then recovering from Slack. Of course, you talk about time-intensive property format, lack of documentation for specific file type. Then beyond fragmentation and time demand, corrupts and damage, false positive to limitation. A balance act of expertise and persistence, while challenge modify carving is an essential practical. So that's why sometimes people, you see them in Discord, and I need the red team rooms, I don't need forensic, because they don't have a patience to so what is the file size of the image we got? Where is the image we got? We got that image with struct TryHackMe, so ls minus la. What's that Linux command to convert it to uh, uh, what is this oh, from the Slack one, so not this one, the one we waiting for our friend to finish. Oh, he finished. If you finish, usually you find a folder called extracted. That's the signature of so if I go, you can just say ls. So we have usually this, you don't let you go to the next one because that's in more binaries. And now we have full logo wallpaper. So let's look at it. The first one was this one. Let's see the second one, how it looked like. TryHackMe, you lost the creation. You don't have. You see here the size is already telling us here 31.8, and then if I go ls minus la, yeah, it give me the image is 31.8. It's said in kilobytes, so I don't know how. So TryHackMe do what I think 32 will not, because usually if you say 31.8, it's basically 32. If you think about it, so it's 32. The Linux will say is closer to 32 because 1,000. So this is the 1,000. So 31.8, 32. But if you put 32 here, it doesn't work. So I assume they just looking for the first digits. Sorry guys. What is the name of the extracted file that has no extension, and that's like doesn't have extension? You can see this extension, so definitely is this one. Let's look what's inside it. Let's see if cat can get it. Run some stuff. Oh, it's a binary. Stop, it's not, we can't cut it. It's already big. We can just see what's inside that. Strings, just push it to header. Head, not header. Interesting. What do you mean string can't see it? Oh, it's big. Oh no, I'm interested now. Not find. What's that thing? It's data, but why I can't read it? So this is the image. It's a 52.8 megabyte. How about I rename to txt? If I meant to, but it can't be. Why the head doesn't work? Nothing. If we do it with Vim, we'll crash it. Let's see. Oh no, we crashing the computer. Just close the tab. I don't want to crash the computer. Our friend is still printing. Oh, it's finished printing. File image. I think we need to clean it or something. I don't know. Hex edit. I think we copied the wrong format or something. We copy this nonsense. We're not supposed to copy this, the last colon and this one. So we only need these values. I don't want to waste everybody time how to copy it. So we need to get Linux command to remove this and just keep that once. So we did a mistake in copy. Yes, just I don't press any key. Whoa. Control X. So we did a mistake in copying. So did it work fine? So we can expect that one. So then we can apply exif tool, and the extracted file we got. CD desktop challenge. We can go exif tool. We know the one that we got Binwalk. We're looking for that image. If any hidden in that image, full logo PNG, and then we got the fragment flag. So we can go there. This is the flag. What that question we jump? Oh, the file we got it. So it's ls challenge. uh, xroot. The name without extension is this one. The txt I just added, now I want to open it, but it doesn't work, so I don't know. The next one is the automatic curving. Now they give us tools. Now efficient and scalability, speed, whatever. Scalp. We're using this one. I didn't use this one. The autopsy. Yeah, the autopsy sometimes is problematic. That one. Enhance the accuracy, algorithm detection, support, and all of that. Ease of use. Now to practice them, we. For example, they're talking about the deleted image. If you mount it, for example, okay, let me go back to want to use. So ls. So if I say this, you do mount, mount, for example, challenge 3 in. You can mount it anywhere. Uh, what that folder again? MNT, yes, it's world famous. Always we mount on it. MNT temporary. So if I say MNT temp, MNT temp, we got lost and found. ls can't open directory, permission denied, nothing. So it looked like there's nothing for us to do that. It directly appear nearly empty, a clear sign that normal file system analysis won't recover anything. Traditional method see no file. So now we're using this file called software that called foremost. So if I go etc foremost.conf, this is the default file that we have of it. So basically it has signature on it. So and TryHackMe, they give us the vim etc custom foremost, and in the custom they activate in the one, like for example look for wave, look for png, look for jpeg, mute, I don't want too much noise on me. So for example here detect GIF, JPG. So this one, I think it's hex for GIF. The signature of the metadata for that, all of that, and then input disk image, output directory where curved file will be written. Specify the path of your custom configuration in letter -c. So now, in case in our scenario, so -i and then output directory. So if remember, for example here, this is the custom one that you can use, or you can use the other ones. Is but not sometimes you need to add signature for it to work. So for software is for foremost -e, the image will go into the challenge number 3. Then it will output directory, let's say directory 3. Let's call it directory 3 because we didn't charge directory 3. And then let's see, we can see now we're not using, we need to use in our custom foremost config. Let's leave it work, and it seems working. Oh, it's too fast. If I go -la directory 3, oh no, we have mp3 audit pdf png. So basically this one is nice, it's faster. Look at the Scalpel. etc Scalpel conf. Let's see if which one of them give us better result. Leave this dot. Let's go there. What the? Scalpel. I think it would be -i, same as Scalpel. No, it doesn't -i, just call straight challenge 3. -o, the output, -o, call it directory 3 scalp, and then use the configuration in scalp config -c etc scalp.conf. Let's see which one give us better result. Oh, they're both fast, ironically. So let's do that. Where ls -la directory 3 Scalpel. So this one got audit and this one got PDF 7. Take note that if you wish to execute the command multiple times, you may wish to delete the directory before running the command. Okay, that's fine. So if we look very well, this one, the foremost, was able to, maybe because of the we didn't add signature in this no in etc carbon. Maybe TryHackMe didn't add all the signatures because this is just give me the PDF basically, and it said there is 00 PDF. Let's go to our desktop. Scalpel was able to get PDF. So now the question TryHackMe said, what is the original name of the recovered PDF file? So you can see it's here. Data. So you can just copy that. Let's see, because we got the same. Let's see what our friend the other one, foremost also got this PA. He has a couple of MP3s, and then he also has a PNG. Oh, he got a PNG when the other one couldn't find it, so at least this one finds some extra stuff. And you got a PDF, same PDF, so both of them got PDF, but one got PDF and the other one don't. And then we have the flag of TryHackMe also here, so we cool in that context. That's the flag in the file. And then what is the flag in the image file recovered? Of course, only one got an image, so this is the PDF. The PNG is here, so this is the image. We only could, so we can say exif tool directory 3. We got a fifth image PNG, and then that's that image we got, and that's how TryHackMe. So the Scalpel couldn't find the image, or is not configured to find it, so we don't blame it directly. So we have the image, and then we have the flag for it. Now, sorry guys, wait, it's wrong. TryHackMe, don't play with me. Oh, it's no. We have spent time in this room honoring your skills in digital file carving and data recovery technique, having learned about tools like Foremost and Binwalk for identifying hidden files signated within binary and hex editor for the malicious inspection of raw data. It's now time to put everything you learned into practice. Your challenge is to examine the provided disk image, Carving Capstone. Okay, and we get all the solution. Let's make sure the timer is still having time there. Okay, let's do what need to be done. Let's close first this. Let's open the DD1. This is the DD1, and then we can do things like we did already. So for example, we can just do the same. We run foremost. Let's run foremost, for example, in this this challenge DD things. What's the name of the challenge? Carving. And then let's call this directory, oops, Carving Capstone, let's call it Capstone Stone 1 because we're using foremost. Here's very interesting part. We'll talk about it. Foremost, let's call it F for foremost 1 because we're using the custom config. Let it run. We can use Scalpel here. Let's see what Scalpel will give us. Let's minus cap. No, caps, no, not before. Cap. Oh, carve. Carve. So cap stone, and because we're in a scalpel, we call it S, so we can remember which one. Let that one run, and then this one run. And I want to show you different because what happened to me yesterday when we use different configuration. If I don't need to use custom, I'm not using the custom, using the default thing. So let's call it 2. So number 2 is using its own default file, not the custom configuration. So we put it in F2 and let it run in F2. So now we have that and we have that. So Scalpel finished. Scalpel, we said we save it in CD capstones and capstone capstone S. So if we go there, what we go with all it, he could find nothing because maybe it's not configured to get anything in reality. So we can just go out. We can go to capstone F1, the one for configuration. Let's call it F1. The F1, what it give me, we have MP3, PNG, and WAV, LS, MP3. That's what happened to me yesterday. I got all of this MP3, and then we have PNG, and then we have WAV. So we have that. Then if I go back now, this one is F2, CD capstone F2. F2, the diffie configuration only give me WAV file, so you can ls WAV. Let's see if the same size, ls minus la WAV. It's a 3 meg 3225. Let's ls minus la WAV. Is it same size? 3225 636. No, it doesn't look to them. 636 and this one. Oh, it's the same. Okay, so both got WAV, but one got also this funny MP3. But it's fine. I was not looking for the MP3. My mistake. Using Binwalk and the hex editor, what is the beginning and ending offset of XML? Now, because it talked me about the XML, so we can just come here, search for XML file. Is Microsoft Office. This is Office, so it shouldn't be this one. I think it should be the normal XML that we used to it, this version things. I'm not sure which one TryHackMe is asking us to use. Let's try this one. It should be text files. Oh, let's try this one because no, that's not Windows script. Usually XML version. That's usually the normal XML that I know. So this one should be the logical choice because XML version. That's why usually XML start with. XML file in disk image. Let's try this. With our So this is the XML file. So we need to search for this signature of the XML. Hold on, maybe TryHackMe gave us this answer already. Let's, where is that basic curve JPEG, PNG, docs, GIF. Oh. Why it doesn't give us XML? Okay, let's take our luck. If we find this, mean we are in the right place. Find. Oh, we found it. As I said, this XML version. So we correct. This is XML version. XML version is same thing. So we know. So how we'll find the end of it? This is the end? This is file signature, but where is the end? You know what? I forgot to find the end, but we know where it starts. So let's first do what we need to start. So we find an XML. Start offset. You can see the offset is here. So enter the 3C. So 013 16. It's in the beginning, this one, so it's straightforward. So it's 013 49 01349. I can't see. It's 49 468 468 16. It's confirmed. That's the line. 134946816 6186. Now where is the end of the XML? So, now I'm confused. I forgot TryHackMe. Why didn't give us the end? This is file signature. Footer end marker. So you think the end marker is this? No, we're looking for the close of XML version. So basically, XML start with XML version and end with XML. Oh, to be lazy, you just cruise down until you find the end of it. You know, the end of the XML. But I don't know how long it will take us to go scroll down. This is a lazy way. We can ask Google. This is a big XML file. Why make our life difficult now? Still not finished. When we arrive to the zeros, we know with the end. We still no zeros. I think I just need to Google the end. This is all of it XML file. Where is the zeros now? You kidding me now? TryHackMe. You see, they didn't took this long. What's the footer now for this? If we know the footer, we just search for it. Uh, we are somewhere. Things with us, otherwise we losing everything. It should be end of the XML. No, that's not the correct one. If it was the XML end, we'll see the XML ending somewhere here. I think we jumped too much down. Okay, we know the start is there. How the XML find format? Let me do this quickly. And then what we looking exactly for the keyword so easy for us to search. Footer and marker. Uh, XML. I didn't. I forgot how I did it yesterday. Uh, you can see 3C3F. What? No. What happened here? 3C3F78. No, that's not the answer I'm looking for. XML forensic hex. I hate Google. The way Google search. XML. Sorry. The XLS. This is the wrong website. It doesn't give me information. And this one you want me to pay for it. I'm not paying for nonsense. Why I'm not able to find the... Guys, give me a second. Let me pause. I don't want to waste people time. I don't know. What's the signature at the end of the XML file? Let me pause it quickly. Hi everybody, I'm back again. Sorry, I was checking the notes of yesterday, so let's go back what we found. We did a search for the XML because we know it starts with 3C, something like that, because usually an XML value, XML starts something like that. So it starts with this. So we did a search, find, and then for the 3C3F, and we find you can see an XML version. Now usually XML version start version like that, and you can see that is a root item example and then end with root. Now you can get the text is root. You can go strength, for example, root to hex, and it start 3C to F. We can go for this root and say let's search for this. You can find any of this at the end, so we know. It seems that there is no like binaries like image you have end of footer. The text files they don't usually have, so you need to search for them in different ways. So if we do that, usually I'm not sure if we'll find it. It said doesn't, but if you look in the beginning here, it said XML version equal 1.0 encoding UTF-8, and then we have SVG. So now there is a different story. It looks in XML, but there is an SVG inside. So now we assume if it start, if there is if there is an SVG start like that, it should end with SVG like that. So you can get SVG block, and then let's convert it to hex, and it's 3C2F73. 3C2F73. We can search for this string. Let's, because this is give us the end of the file. So if we go there, no, that's 6, and then let's see. So let's see if we can get the SVG end of it. That's so if we go find, so if we get that, no, don't joke with me, it doesn't find it. You find the SVG block code. What did you convert us? 673E. Yeah, this is the why it doesn't. Why I couldn't find when I put 3E here. Huh. Oh no, and select this. Now we found it. So 3C2F7376673E. So we got the end of the file. So now what we supposed to do again? What is the beginning and ending offset of the XML file? Well, let's start with the end. Did we took the beginning? Ah, we didn't write anything. Eish. We're not smart. We supposed to 3C3F is the start. Let's get the start values first. Before no, it's start. Let's get the start value first. What's going on now? 3C3F786D. What did I put here? C20 65. And why it keeps selecting the bytes? Okay, we know the start is this. You can 013. Let's put that some because we need now the offsets. We already typed the offset 6816, so we have the offset. Okay, let's search back in the end of the file. Find, remove these select things. So this is the end of the file. So if we do Remember, not like the binary, we took the byte here. So now I need to get the whole file from what the question is, what is the beginning and the ending offset of the XML file? So if I understand it correctly now, we're not like the binaries, we need to give the whole things. The binary ending here, so it give me, if you look in the bottom here, it give you the start end, so you can do the same as TryHackMe. 0 1 3 5 0 1 2 6 1 9. So you can do it in this way because you know it's in the bottom, or you can do what we did before. We can just do the line here. It's 0 1 3 5 0 1 2 5. No, I'm confused now. This line 135012608 0126008 plus the offset. How many bytes? This byte is 0 1 2 3 4 5 6 7 8 9 10 11. So if it's here, if you put 11 here, we get this value, the 19 value, because 0 8 11 19. So we can, so this is the start to the end of the offset. Should be this one. The 0 of TryHackMe doesn't want 0. It doesn't see need the leading 0. So 1 3 2 6 1 9 2 6 1 1. I want to TryHackMe now. 1350 1350 12619 1 2 1 2 1 2 619 619 should give me the answer. That's now what is the actual file type, because now because you can see we can check it when we get it, but remember we talk about an SVG here, so it's an SVG file. And then how long is the playback from the audio? Now remember we can get this file. Let's extract it. Dun, 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 dun. To extract it we can use where is that things? The D things. Let's try the D things. This is a challenge 2. Did we do anything? Oh, we got the wave file. We did the Carving Capstone, but we didn't do the. Let's do this. No, we know the start is the start is this one, and then this is the start with our calculator. Let's put that there. This is the start. Sorry. The end is this one. So the end minus the start, it gives us this value. So if I go there, I can change the count here. And then we need to change this if challenge. And then it's not image because we thought it is XML. Let's call it XML. Let's say tryhackme.xml for now. then we can go file and then tryhackme.xml, and he said it's an SVG, so you can just move tryhackme.xml to tryhackme.svg. No, how to open it? No, you can just it's a text file, so Vim should open it. This is the SVG now we got. Let's see how it look in real life. SVG challenge TryHackMe SVG. Open it with, let's see, can't open it with that Firefox. The next one talked to me about hey, that WAV file. The WAV file, we got it in Cartas. This, because remember we already did when we start we did a command for foremost for this. We already did that job. Oh, because of the XML file, can we fix it? Because it's not XML file. Let's close that XML file, remove that line, Ctrl Shift G. So let's remove, let's see if we can. We did something wrong? Oh, we didn't copy the whole thing. You see, guys, I missed something. I think I missed. I missed the. Oh, that's offset 19. Why? We did something mistakes. Maybe we didn't copy the last character. Oh, now we got. Yeah, that's nice. TryHackMe. Yeah? Nice image. Okay, I don't know how we missed that one. The next one, let's finish quickly. I think we can answer this quickly. We already did. We found the image. This one only found via the image. Did we try the lspng? So we can go exif tool png 00, and we have the flag, and we can check what image. Capstone F1. Let's go to see the image. Why not see them? We don't just get the flags. Capstone 1 png. What image TryHackMe is giving us? Really? Why it's broken too? It's a corrupt image. Let's see. No, F2 capstone F2 didn't even find it. So the image is corrupt, but we're able to get the flag. Why the image is corrupt, guys? Where we found the image in why it's corrupt? Hex edit. It's a PNG. So why it's not in correctly in the magic? Why exif tool he read it fine. Any case, I don't know to be honest. How long the pay the I mean how long this audio file for the WAV file? Where is that WAV file? I don't know. I forgot that command in Linux. Let's see if we can do shortcuts. The WAV. Let's play. How long it will play if we play it in the music? That's the playback. time 018. Yeah, it's not 018 exactly. Uh, it's 18 something, but what's exact time? You see, they say 18, but it's 18 and something. Doesn't show me exactly. Let's see if the proprietary can proprietary give me the. I'm doing something funny now. Exif tool is for images, it's not for sound. Oh, you give me duration. Yeah. This is a Linux command. I used it yesterday. I forgot about it. So Exif tool also can give me the answer. Okay, that's fine. Yeah, I think we did the room. The only problem we got is we got the image, the SVG. The only thing we couldn't open is the PNG file. I don't know. Capstone one is this PNG. I don't know why it's not corrupted. In any case, guys, thank you very much, and yeah, hope you like it, the room. Please press like, support the channel. Please, thank you very much, and yeah, and have a good day. I know it's freezing.